Welcome to the AirCon Vault, recordings of the live streams from AirWiggle's audio conference. These are made free thanks to our sponsors, A Sound Effect, Game Audio Learning, Kilohertz, Audio Kinetic, Sound Cuts, Tsugi, Boom Library, Sound Warriors, and AirWiggles, the online home for audio people.
So I started experimenting with data exchange via OSC because I was working on an installation that uses a self-built EEG device to generate music from the user's brainwaves. And I wanted to create an immersive installation, a VR installation. So I started working with Max to generate the music and to drive the spatialization music and sound engine, and Unreal Engine as the graphic VR engine. So today I'm going to show you how to do that. Let's start with Unreal. Unreal has the OSC plugin that you have to activate in the plugins tab. So go into plugins and type OSC, and you have to enable this one, OSC Open Sound Control. Open Sound Control is historically has been used for live music interaction between softwares and between hardware and software. For example, if you have, I don't know, a gyroscope, you can send information from that to your MaxMSP patch via OSC. In this case, we are going to send the data back and forth Max and Unreal. Here in Max, I created this simple patch. So this part is just a MIDI controller I'm using to control this XY controller here. And this one is a simple LFO. This one here. The important part in the Max patch is this. This block here. Odot is a CNMAT library that is been explicitly created to handle OSC data, and it's great, and is the best thing you can do if you want to work with the OSC data. So here, if you see the syntax is OSC syntax, I'm sending those messages to the UDP send with the localhost IP and this port. You can use any port. If you see the OSC syntax is specific, you have to send messages with a specific name. So here I'm sending X and Y. And if you see the message, it's X and Y. And I'm sending also the LFO from here. So the odot pack has an hot inlet, and the other ones are cold inlets. So you have to send also a bang to the hot inlet. So the block is sending the data every time any of those change. So here you can see here I'm sending those data. To send the OSC package, because basically here I'm getting those messages and packaging them into an OSC message pack. Via the UDP send, I'm sending this to anywhere really in the computer. Here I can test if it's been received. I'm using the spat5.osc.udp send object. There is an object from the spat5 library that is an IRCAM spatialization engine that is really, really powerful. And later I'm going to show you also other ways to use it because it's very stable and transmits OSC data without losing packages. You can also use the normal UDP send object, and again you have to specify the IP and the port, and if at the end you write CNMAT, it is going to be more stable for OSC packages. So this one is a very simple patch just to send some numbers out in the OSC stream. Let's go and see how we can get those numbers inside Arial. In Arial, I already created all the blueprints, and I have this OSC in blueprint here. If you want to create it from scratch, you just have to create a blueprint class and an actor and call it OSC whatever. And remember, you have to place it inside the 3D world to have it working. I have the OSC in here. In the OSC in blueprint, I created an OSC server that when the game starts playing, creates the OSC server again with the same localhost IP address and the same port I'm using in the MaxMSP patch. So same port. You can use as many ports as you want for different OSC packages. I placed the server name as Max as the name I placed here in the OSC messages from Max. So you can see the messages are Max X, Max Y, Max LFO. I simply set the variable OSC server max. So from return value, I promote it to a variable and bind the event to on OSC message received. That means that I create this custom event that when OSC message is received from Max, so now there is a constant stream of messages from the LFO message, and if I want also from this XY tab, get the OSC message address. This is just for debug, so the important part is this. And I convert the OSC address to string so Unreal can understand what is being sent, in this case numbers. And I route every single message, so it's the same name as the messages I have here. Again, maxx, maxy, max LFO. I route them and I get every single message from here. So the message that is received as a package here is being split to each single message. In this case, three different messages. The X message, the Y message, and the LFO message. So from here, I have a value. And with this value, I can do whatever I like, really. So in this case, just to test it, I created a particle system and two lights. So I'm going to dim the lights and drive the particle system through the OSC data I'm sending. Here, for the X value, I simply clamped the value, the input value that is, if you see here, is from 0. So XY value of this pad is from 0 to 1000 for each. But this is completely arbitrary. I mean, you can go here and change the value as you like. But in Unreal, I needed a value between 260,000 to drive the force inside the particle system. So I mapped the input values to those values. I did this for the particle system, and I mapped this, the same input value, to 0 to 100 to send it to the lights. I did the same for the Y value. So this part is going to the Niagara system, and this part is going to the point lights. And I did exactly the same for the LFO. The LFO, I'm only using it to control the noise strength inside the Niagara system. So in this blueprint, I have the OSC messages ready to be used. Now let's go and see the particle system. That is this one. I created this particle system from an hanging particulates basic system. It's using mesh renderer, and so I have those user parameters that are the parameters that are coming from the OSC blueprint. I have user noise strength, I have user turbulence, I have user vortex force. If we go and search for where I use that, inside the wind force particle update block, I used the user turbulence parameter to drive the scale of the particle system. To do so, you can either create here a parameter, and then you can drag and release it here, or you can search for your user parameters inside here, and you can choose which one of your user parameters you want to use. And I did the same for the vortex force amount, vortex force, and also the curl noise force. I have the noise strength here. So doing this, I have basically Max that is hardwired to the particle system. Inside the OSC blueprint, I have to create a reference to the Niagara system here. So I created a variable from here and choosing a Niagara actor object reference. That is this one, this Niagara reference. And I sent the value, the mapped value, to this Niagara ref through this setFloat parameter. There is one last thing to do, that is place your Niagara system inside the project, go to OSC in, and then you have to reference your Niagara system, your Niagara reference. So this block here, in the OSC in block here. Basically, you have to tell this OSC blueprint which Niagara system you want to control with those OSC values. In this case, this Niagara system. And it's exactly the same for the lights. I have the value mapped here, and I send them to set the intensity of the target light component. And I created 2-point light references, so variables, sorry. I created a variable here, and then point light object reference, those two, and I have the object references. Again, I have to go, sorry, to my OSC blueprint in the 3D world and reference the lights I want to control inside here. This way, I can show you now. I hope you can see that because it's slowing down. Now I'm controlling the lights and the particle system through the OSC data I'm sending. Yes, you can really do everything. Just your imagination is the limit. And as you can see, okay, here with the X axis, I'm controlling the orange light and the noise strength, the current noise strength of the particle system. And with the Y-axis, I'm controlling the blue light and another parameter of the particle system. So think if you have those parameters somewhat automated, or for example driven by the user's brainwaves or any other physiological parameter. For example, the heartbeat. You would have this particle system going with your heartbeat. No, yeah, the power of Windows. Yes, there is. My GitHub here, and you can download the project files and use them. And also modify them and do whatever you like with them. Because again, you can connect here instead of this MIDI controller. You can connect everything. You can also like do some FFT analysis on some music, and then connect this analysis to the particle system and have like a music-driven particle system. You can really do whatever you like because those are just numbers. So you are exchanging numbers between software, and really there is no limit. Yes, like I'm really interested in hooking up the brain to the computer. So now I'm working on an app with this 8-channel EEG device. It has 8 sensors, and I'm working on an app to generate music for biofeedback, to teach people how to relax themselves, how to control their emotions. And in theory, you can also use that to control, I don't know, the weather in a game, in a video game, or the music, I don't know, the intensity of music in a video game based on your arousal, on your brain activity. Yeah, you can. Yes, meaningless numbers. Exactly that. Yes, you can use breathing. You can really use any type of sensor. I don't know if you have libraries inside Arial that let you use sensors, but you have a lot of libraries inside Max that let you use sensors. And those sensors are sensing the analogic world and transform the world into numbers. And then with those numbers, you can do whatever you like. So this is one part of the project, but there is The second part that I love so much, that is a 3D granulator made with another IRCAM library. If you don't know IRCAM is one of the center of excellence for experimental music and sound. They experiment a lot with sound. They create many softwares, a lot of libraries for Max. Max itself has been pretty much, it's not created there, but they do a lot of collaborations. The XY here, the XY position, I wouldn't say they control the position of the particles, but they control the noise strength and some particles parameters. So if you see, now there is no control, no OSC control, and the particle system is going quite randomly. But if I start controlling with the x-axis, in this case, you see how the particle behavior starts to change. They are going in circle, and if I also use the y parameters, they change behavior as well. So I can play with this and have them and you have to check the reference inside the particle system. You have your user parameters that are driving the wind force turbulence scale, the vortex force, and the noise strength of the curl force. But this is not the best part. The best part is the 3D granulator. So for this, I use the MuBu catart library that uses corpus-based concatenative synthesis. That is basically a sort of granular synthesis based on sound descriptor analysis. So we can decide to use any of those parameters, descriptors, the frequency mean, the energy mean, the periodicity mean, AC1 mean, I don't really know what it is, but yeah, whatever, the loudness, and the centroid or the spread. In this case, I'm using centroid mean for the x-axis and the periodicity mean for the y-axis. So I loaded an audio file here. Just choose an audio file, one of yours, and it gets loaded here. So if I move the mouse here, you can, hopefully you can hear the sound. Can you hear the sound? Yes. If I change the descriptor, let's say, let's use frequency mean, it changes. It changes the organization of sounds, of the particles of the sample used. So I was using this, and I said, okay, why not transform this into a 3D granulator and use the descriptors here as position to create spheres inside a real engine. And I show you what I did. Hopefully it won't crash. This is so to have it working, you have to press play in Unreal and then go to the max patch and press on dump. And then yes. So now we have the particles in the max patch here inside Unreal, and I can walk through the sound particles and have them playing. They are also specialized, but I think you cannot hear that because the audio streaming is mono. So this way you have a 3D granulator using concatenative synthesis from Max. I love this so much. I'm so proud of it. You are the granulator, yeah. Yeah, I don't know if you are hearing the audio how it should be, but you can try it by yourself with the project files. So now I'm going to show you how I did this. So the basic patch here is from the one of the catart library tutorials. What I did is I created the server, the OSC servers and clients to send and receive the data. So from Max, I'm sending. Sorry, it keeps okay. From Max, I'm sending the descriptor data of each sound grain. So for each sound grain, I'm sending the X, Y, and sides data. So what I'm doing, I'm sending OSC packages. I'm sending everything really. I'm sending time, frequency mean, energy mean, periodic mean, AC1 mean, loudness mean, centroid mean, and spread mean, in case I want to use them also for other things inside Unreal. So when I press dump here, this is what I get. This is what I get for every single grain of the sample. So here I have the size of this granulated sample, that is 441 grains of sound. So I have this repeated by 441. Again, I have to pack everything inside an odot pack block, send the OSC messages with their name, so mubu, that is the, let's call it server name, and time, frequency, energy, period, this is the name of the single OSC message. All sent again via spat5.osc.udp send localhost, a different port than the port I used before, of course. And everything is being received inside Unreal into the OSC receiver granulator that is also inside the 3D world here. You have to put it here also because this is the zero origin of the construction that we are going to do inside here. So again, as before, I have the OSC server that is receiving the OSC data from Max. I have the event begin plane, create the OSC server, again localhost, the same port used in Max, set the OSC server. This is probably useless. I can just connect it to bind event to an on OSC message received. There is a custom event I have here that when an OSC message is received, I get each OSC message address and split them inside this switch on string. This switch on string that gives me each single OSC message. And then from here, I have all the different blocks that give me the actual OSC message. So in this part here, I'm getting the values of every single OSC message. So now this is different from the one before because here I have a package of data for each grain. I don't have just one number. I have like 8 values for each grain of sound. So what I need here is to create an array for every single parameter. So then I can create an array of spheres to go and actually create all the grains I need. So for each OSC message, I create the array. So time messages, time array, frequency messages, frequency array. And I'm going to have the sides of the array as the sides I have here of the amount of grains I have, 441. I had to put a delay here because it gets some time, some milliseconds to get all the grains data inside the real. So it took me a lot of time to get to manage to create this structure. It wasn't really straightforward, also because there is no documentation about this, and I'm not really a real programmer, so it took a lot of exploration and a lot of errors to get to this. But then, yes, I made it. So also finished the resizing of the spheres array. I have this custom event unfinished that triggers the actual construction of the spheres array. I have another delay. Then a for each loop that for each sphere I need the construction and the x, y, z and the sides of each sphere. So here I have the centroid mean array, that is the x value of the position, the periodic mean array, that is the y value of the position. I send them into the make transform together with the sides that is given by the energy mean array. So I have location and scale for each single sphere, and then I just add a static mesh component for each grain of sound, and then set the static mesh. So in this way, I have the construction of the granulator. But then I have to send the player position back to max to drive the granulation engine, because I need the player position basically to be like the mouse pointer here. So I have created another OSC blueprint that takes the player global position and send it to max. Also, there is some math because I want the granulator to be restrained in a certain space and not to be all over the place. So I decided some minimum and maximum value in which the granulator should be, and I did the opposite. So I sent the minimum and maximum value of the constrained space back to max, because I need the value that inside max go from 0 to 3000 and 0 to 70,000 to be 0, 1, because the position of the mouse on the screen goes from 0 to 1. So I have to map and remap those positions to get the final right number at the end. So here I'm getting the player position. I created an OSC message bundle. So I created OSC message bundle and then get OSC messages from bundle and send them as a bundle, again as a OSC package to max. Again, IP address is the same, a different port. So I'm sending X, Y, and Z position to max. Here I created this receive, where I receive the data from a real. I use the odot route block to route the each single message, basically to unpack the OSC bundle that is coming from a real and have every single message to be routed to where I need it. So some scale again to have at the end 0 to 1. In this way, I have the player position in Unreal driving the pointer on the granulation engine. There is also another thing that is really interesting, that you can get the player rotation. How can I use the player rotation? There is another IRCAM library. It's always that is the SPAT library that is used for ambisonics and binaural development. So here I have the spatialization engine. Those are sound sources. I can move whatever I like. And this is the user's head position. So what can I do having the player's rotation? I can control the user's head rotation inside SPAT. I'll show you. You see, so here it's 0 degrees. The head is facing forward in max. Then here it's facing right. Here it's facing backward, and here it's facing left. So you can have sound sources inside Max and have the spatialization engine be driven by the user position inside a real. This is really good when you are working with VR, because you can have your VR headset with headphones and work inside this world and have all the spatialization engine managed by Max and the SPAT5 library. I did this the same way. Sorry. So I'm receiving the yaw rotation from a reel, and I'm sending it outside this patch and into this simple rotation patch that uses OSC messages again, because SPAT5 works with OSC messages. And I'm sending this rotation inside the SPAT5 operator. That is the perceptual operator that controls the spatialization engine. So in this way, I can also connect objects in a real to some sources spots. Yes, I can definitely do that, because I can modify the sound sources position inside Max from any number is coming from anywhere. So yes, of course, also inside inside a real. I can also like having those sources moving inside Max and then send the data inside a real and have them be represented by, I don't know, an object inside a real. You can do all this back and forth, because once you have the connection, once you have the send and the receive, you can send everything you need. So here I'm sending data from Max. Here I'm receiving data from a real. And this I mean, sadly, there is basically no documentation about this because no one is doing this. Because probably there are like other ways to do it, but I don't know. I like this way of working, and it works for me. And also, again, in the blueprints, you just have to create the OSC server to receive the data, and then unpack the messages and send them to the get OSC message, and then do the math you need to do whatever you need. And it's the same to send the data. You have to create OSC bundles, send OSC bundles, and then create set OSC message address, add float to OSC message, that is the value that you need to send, and then add OSC message, and you have OSC bundles to send outside the real to wherever you like. So this is it. I show you again. Think that if you have like those connected to your heartbeat, for example, and then you could have also like the light inside the granulation spheres connected to your heartbeat, and then you walk inside your granulator with the spheres going with the rhythm of your heart. Everything you like, really. Sorry, there is no sound. Also, this is like a very simple project, but you can make it more complex and add many inputs and outputs, control a lot of different things. Yes, this is it. So check again. I can paste here my GitHub where there are the project files. Use them, modify them, let me know what you're going to do with them. Send me messages, emails. Do you have any questions? Thank you. I really like it because, I don't know, I have this thing that I love to connect things. I explored the meta sounds for another project. I didn't really merge the two projects, but you can do that. Absolutely. You can also, in Max, there is it's a plugin, a library, I don't know how to call that is called Rambo, where you can have a Max patch transformed into a C++ library. And then you can use that C++ library inside Unreal as a plugin. So you can do many different things. Thank you very much. Thank you. This was my first time explaining things online, so it has been strange to not have like people physically here. New job titles coming from this. No, thank you very much. Thank you very much. Let me know what you're going to do with this. Because yeah, there are no limits. Meaningless numbers. Wonderful. Thank you very much. Thank you. And if you need any help with further development, just write me, send me an email, or write me here on. Interactive sound designer, yeah. Yeah, you can write me here. Wonderful. Thank you very much, everyone, and enjoy the rest of the talks. Bye bye.